Hey, what's going on, guys? Let's do this problem right here. The question is asking an alpha particle is moving to the right at 5000 meter per second. What is the magnetic field at a point 10 centimeter away and directed 45 degree above the positive x-axis? So let's see how we can find it. So first of all, alpha particle is basically the particle with two protons and two neutrons, right? It's actual nucleus of helium atom. So this is going to be the alpha particle, and then they are saying this particle is moving right at 5000 meter per second. So this is going to the right at with 5000 meter per second. So velocity is going to be 5000 meter per second, and this is in the x direction, right? So this is going to be I cap. And then the question is saying magnetic field at a point 10 centimeter away and directed 45 degree above the positive x-axis. And we know that right side is positive, and above 45 degree from this positive x-axis, so it's going to look like this, 45 degree, and also the distance is 10 centimeters. So this distance is 10 centimeter right here, and this angle is 45 degree, right? 45 degree. And let's see how we can find this. Okay, first of all, we have to find the direction of this magnetic field too, right? So to find the direction, what we do, we point our thumb toward this velocity direction. So for example, you're going to use the right hand. When you point the thumb in the right side, this side, directed toward the velocity from the right hand, so your hand is going to look like this. And when you bend the hand, that is the direction of magnetic field. So here the direction is going to be coming outside of this board, right? So the direction is going to be dot. We put dot, it means coming out of this, and that's going to be the direction. And let's see how we can. So it's going to be in a circular pattern. So from this information we have to find the magnetic field, right? So let's go ahead and plug the equation first. To find the magnetic field, we use this equation. B is equal to mu naught Q V cross R divided by 4 pi R square, right? So here, instead of cross R, we can put sine theta. Mu naught Q V sine theta over 4 pi R square. So both are same equations. Now we know that angle already, that's 45 degree. So this is going to be sine 45 degree. Here we have mu naught, that is 4 pi times 10 to the power of minus 7 Tesla meter per ampere times the charge. It's going to be charge of the protons. We have two protons right here. So we have to multiply this one by 2. 2 times one proton's charge is 1.6 times 10 to the power of minus 19 coulomb. So this is going to be 2 times 1.6 times 10 to the power of minus 19 coulomb, right? And the speed is 5000 meter per second. So we multiply this one by 5000 meter per second times sine 45, right? Divided by 4 pi R square. 4 pi, and the R is the radius. Radius is 10 centimeter. We have to convert this one into meters. So this is going to be 0.1 meter square. So we are going to have 0.1 meter square. And if you plug all these value in calculator, you're going to get 1.13 times 10 to the power of minus 13 or 20 Tesla. So this is going to be the final answer. And let's see how we derive Tesla from this one. So here we had Tesla meter per ampere times coulomb times meter per second divided by meter square, right? And ampere is basically equal to coulombs per second. So we can plug coulombs per second this instead of this ampere. So this is going to be Tesla meter per coulombs per second. So this second will flip around and go to the top. So this is going to be Tesla meter second per coulomb times meter per second over meter square. So here if you notice that coulomb cancels, meter square and these 2 meters cancel and this second and this second cancels. And finally you derive Tesla. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.